So welcome back once again to our live session today. So in today's video, we are continuing with our discussion on measures of central tendency. So the last time we had some small interactions, so the video ended and we couldn't able to finish that lesson. So we are continuing with that discussion, and then we started by looking at the definition of a measure of central tendency, and we said with that we have the mode, we have the median, we have what the mean. But we started by looking at the mean, and we said the mean actually also have three parts, being the arithmetic mean, the weighted mean, and then that of the geometric mean. And then when we are discussing these items in that line, we talk about the arithmetic mean, and we be able to perform two calculations, which were including the sample population mean and then sample mean, and then that of what population what mean. And then I think from there we discussed the weighted mean, that of what the geometric mean, and we ended on the median for ungrouped data. What we discussed last time was for ungrouped data. So if you haven't watched that video, the link is on the description section of this video. Please do watch before you proceed to this video. And make sure to like the video and share. By this way, the YouTube algorithm will push the video so that others will get the benefit to always to watch from this channel in that line. So thank you once again for joining us on this session. So today we are continuing the discussion by looking at what the median for ungrouped what data. So thank you for joining us. Please do all to like the video and share so that others will get a benefit to join us in that line. So as I said just now, we are continuing the discussion by looking at median for ungrouped what data. So the last time we said that for median, we want to locate the middle value of the set of data. I want to know the center of the data. And we have some key takeaway that we actually took the last time. We said that if the number of data involved is an odd number, then to find the median, it should be what? Half of what? N plus 1, where the number of data involved is what? Odd number. But if the number of data involved is what? An even number, then it is what? The average of what the two set of values involved, so that you find the median in that line. So we wanted to support that with an example, and that was when the video actually ended, that we actually uh wasn't our control, so we couldn't be able to actually to control that line. So that's what we are looking out. Actually, that's what we are looking out. So let's see. So we have an example here that we are asked to solve. We have an example that we are asked to solve in that line. So we have example 1. It said we are asked to solve example 6. This is actually example 6 from the previous lesson. So we are asked to find the median of the following data. So we have I, 7, 9, 8, 10, 15, 25, and then 4. Okay. So how do you find the median of this particular data? Before we can do that, let's count the number of data involved here. So we have how many? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is an odd number. So meaning that for us to find the median, it should be what? So we say that so let's have our solution here. We say that n is what? 9. Okay, so to find the position of the median value should be what? 1 over 2 of what? N plus 1 position. But we know that n is what? So that's going to be the median what? Position, the mid position. Okay, so therefore we say that 1 over 2 into bracket n is what? 9 plus 1 of that n position. So what are we getting? So we will say that 9 plus 1 is 10 divided by 2, we are getting what? 5. So it should be the fifth what? Position. So before you can find that value, you must also arrange the data in ascending order of what? Magnitude. I believe that is clear. So in that line, we will say that in arranging this in ascending order of magnitude, we start by what? Say that it should start from what? 4. From 4, we move on to 5, then 6. We have 7 there. We have 8. Yeah. We have 9. Then we have what? 10. We don't have 11, but we have what? 15. I hope that is right. And then we have what? 20. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So once you're able to do that, we are saying that the median values for the fifth word position when you count in that ascending order form. So that should be what? So 1, 2, 3, 4, 5. So meaning that the median value should be what? Should be what? The fifth word data, or the fifth word value from this set of data. And we will say that therefore our median is equal to what? 8. Our median is equal to what? 8. Because we're able to identify that the median position is what? The fifth word value. And that is what? In this particular case is what? 8. So let's take note of that. Then II2. So you're asked to find the median for the II part of question. This is 10, 20, 30, 50, and then 60 and 25. So how do you also find that? So in that too, you must know the number of data involved here. Okay, so you have what? 1, 2, 3, 4, 5, 6. So how many sets of data we have here? 6, right? So meaning that here our n is what? Our n is equal to what? 6. So therefore, our median value should be equal to what? Being an even number should be equal to what? 6, right? So for us to half of what? The 6, and that should give us what? 3. So that's on the third word position, sorry, on the third word position. So let's arrange these values in that ascending order, right? So we have what? 10. Okay, from 10 move on to what? 20. Then 25 is here. Then we have 30. Then we have what? 50. And lastly we have 60. Okay, so meaning that we are saying that the median position is on the third position, right? So we have what? 1, 2, 3. I remember this is a third one, but you ask yourself how many sets of data you also have here. When you also count from the back two, we have what? So 1, 2, and 3. So mean that since an even the number of data involved is an even number, then the third position is going to be within what? That of what? 25 and what? 30. So we always count from the beginning part of the data and then the ending part of the data, right? Where you have arranged them in what? In that ascending order of magnitude, right? So likewise, what we did for the first one too, we would have also said that when we count in that line from the backside of the data, 1, 2, 3, 4, 5, it will fall on what? 8 has been the fifth word value. So you do for both at the beginning and at the end of what? The data. So meaning that here our values are on the third position is what? 25 and that of 30. So the rule tells us that if it's an even number, then we'll find the average of what? Those values involved. So we're having what? 25 plus what? 30. So what are we getting? 25 plus 30, we are getting what? 55. So half of 55, we are getting what? 27 point what? 5. Let's see if that is correct in that line so that we'll know that I'm right. All right. So that is that for that of what? The median in that line for ungroup what data. So let's take note of that. Let's talk about the mode for also ungroup data. So let's discuss the mode. So this a simple thing. When we talk about mode is what the key takeaway here is that is the most occurred what data value or the most occurred value in a data what set, right? Or the most common word value in a data set. So let's take note of that. Let's take note of that. So here, let's have an example to support this in that line. Let's say I have what these values. Let's say 2, 2, 4, 6. Let's say 3. Let's say 1. So from this set of data, you ask yourself, what is the mode of this data? What is the mode of this set of what data? We will say that the mode is the most or the most frequent occurred what data, or the most frequent occurred what value. Is that okay? So we'll therefore say that the mode for this data is equal to what? 2. Because we have 2 in a group of what? 2 times. But the rest are just what? 1 in terms of their frequency. So let's take note of that. We can also have this set of data. Let's say this I. Let's say we have 6, we have 7. Let's say we have 8. Let's say we have 9. We have 9. Let's say we have 10. So this is also another set of for data. We asked to find the most. What would be the mode? The mode is the most occurred word set of value, or that has a highest word frequency, or the most common value within a set of data. So therefore, we say that the mode is also here. We have 6, which is twice. You also have 9, which is also what? Twice. So that should tell you that the mode is actually what? 6 and what? 9. And at the same time, we have a mode where the values is more than what? 1. Then we say that such mode is what? A bimodal. A bi what? Modal. Bimodal means what? It's a mode value in which the values involved are twice, right? So when you have a mode value which are twice, then is that is refers to as a bi what modal. But if it is 1, then that's what a uni what modal in that line. So let's take note of that. So that is for all about how to locate the data for group what data for group what data. So let's zoom our attention to discuss what group data for these measures of central tendency for mean, the median, and that of what the mode. So what we have discussed was for group data. So let's move on to discuss for group data. So when we talk about group data, it is a set of data that is in the form of what? In the form of what? Classes, or in the form of what? A class what? Interval. I believe that is clear. So here, group what? Group data for measures of what? Central tendency. So from that line, we're going to start as we started with on group data, where we look at the mean and that of the median and that of the mode. That's the same format you're going to follow through. Also discuss what these measures of central tendency for what group what data in that line. So we begin by looking at what the mean. Begin by looking at what the mean. Begin by looking at what the mean. So generally, to find the mean for group data, as we have already discussed, when we talk about group data, there are a set of data that's within in the form of what classes. Those data are found within what classes, right? That have their class limits, being the lower class limits and the upper class limits. So when you see a set of data that is within classes, then we have what a group what data. So generally, to find the mean for what a group data, we have 3 methods that we're going to go through to discuss here. So we have the general or the normal way of finding what a mean for what a group what data. And we always say that S bar being representing the mean of the normal what way of finding the group data. So I used subscript n to represent the normal instead of what find the mean for a data. And that should always be equal to what summation f of x over what summation what f. This is a normal way of finding what the mean of what a group of what data. So this is going to be the first what method. This is going to method what 1. Is going to be method 1. Okay, what is the method 2 involved? The method 2 involved is where we assume what the value of the mean. Remember, if you are making assumption, there is possible of what making what deviations, because you are not sure whether what the assumption what you are the assumption you are making, whether it's a true or not. So assumption comes with what deviation. It can be true or it can be what false. So in that line, we may have a positive deviation or you may have what a negative what deviation. But anytime you are using assume mean as a second method or the second formula, then there's possible for deviation to what occur. Okay, so now let's see. If you are using what assume mean in that line, so that becomes what the second method. So assume mean, assumed, assume mean, assume mean. So when we are using assuming, then there is deviation. How do you calculate deviation? We say that deviation D should always be equal to what? The values of what? The data set, right? Which is represented as x minus what? The assumed what? Mean. So the d represents the deviation, the x represents what? Each value in a data set, and then a represents the assumed mean. And we'll have a question to discuss this in 10 ways so that you understand it better in that line. Okay, so this is how we calculate what? Deviation. Okay, so if that is the case, then we'll say that I hope I can make x from this what equation, right? So if I want to make s from this equation, okay, I will say that here I'll have what? D, then the a will join the d, so making it what? Plus. Okay, and that should be equal to what? X. So from equation 1 being the first formula or method 1, we can say that for me to actually find the mean for assumed mean, I can replace whatever I see as I can replace what the value of x into equation 1. Yeah, and I think that is will be possible, right? So I will say that therefore my mean for assuming, so I use what? S bar subscript what? Capital A represent the assumed mean to be equal to. So from the normal formula, we'll say that I'll have what? My summation f. Whatever I see x, I'll substitute in place of that. I'll have what? D plus what? A. Okay, and then divide by what? My summation f. What is happening here? So in this particular case, we can therefore expand this word equation by saying we're going to have what? Summation f d over summation f plus we're also going to have what? Summation f a over summation what? F. All right. So once we are getting this, that's fine. So this is what we can do for this. You can clearly see that the summation F can also cancel summation pair that where the deviation is involved, we should always attach the deviation value to the summation F of X. Summation F, so that we have a feel of what we want to explain at the end of the day. But this one, we can cancel this one straight away. So we'll therefore say that we'll have what? Summation FD over summation F plus what? So when this cancel this, we are left with what? A. So this is how we also find what? The mean using what? Assume what? Mean. So we are also find, and that we'll find a mean using what? The assume what? Mean. So this becomes what? Method what? 2. So from method 1, we're able to get what? Assume. Because we say assume mean, there's chance of what? Deviation that is likely to what? Okay. So let's take note of that. If you have any question, you can drop it in the comment section so that we'll take it from there. Okay, so let's continue. Let's continue in that line. So that is for assume what mean in that line. Then the third method we're going to discuss for mean is also where we want to actually let's say want to introduce another method. We call that method as what? The coding what method. We call the coding what method. The coding what method. So from the normal method, move on to the assume mean method and come back to what the coding what method. So what does the coding method says? Unlike the normal way of calculating mean, that of the assumed mean, when it comes to the coding method, it makes use of equal class width. It makes use of equal class interval. By equal class interval, I mean that the width from one set of class interval should be the same thing as what? The width of what? Another set of class what? Interval. So unlike other two mean you have calculated, for the methods, for coding method, you must have what? An equal class width. An equal class width. And as you move along, you also get to appreciate if you're a first person, first time of visiting on this channel, maybe probably you haven't watched that video, so I can give you a gist about those information. When we talk about the coding method too, the coding method too also brings in what? The class what? Width, the class width. So in that too, we introduce a variable called what? U. Not necessarily u, but we call that as what? Mu. Instead, we call it as what? Mu, mu. In that line, you see how they sound, mu. So we use that mu, and that mu is what we bring on board as what? A variable, right? And we say that that mu should always be equal to what? D over what? C. That mu should always be equal to D over what? C. The D represents the deviation, the C represents what? The class width, right? But from the onset of our calculation, we said that deviation is should always be equal to what? X minus what? A. I hope you remember that. So we will say that our mu should be the deviation for which you know it should be X minus what? A. And we know the C to be what? The class what? The class size or the class width in that line. Okay. So from there, then we can as well also deduce some information from this word formula, right? So if I decide to make D the subject being the deviation, so I can substitute into what? The second word formula. What will happen? Let's see. So I would therefore say that here, making D the subject means that this will multiply, the mu will multiply what? That of what? The class width, right? So we're going to have what? D. I'll have what? U, or the mean, being the what? The mu. I'll just use U for explanation purpose, but this mu multiplying what? C, and that should be equal to what? D. So we therefore have what? The mu multiplying whatever I see. So this becomes, let's say, equation 2, right? So whenever I see D, I'll substitute what? The mu value and then the C as a class rate there, so that we'll see what will happen at the end of the day. So therefore, I will say that from this deduction, I will say that therefore to find what the mean for using the coding method with what subscript what C, that should be equal to, what I will do here is that whenever I see D, I'll place what UC for purpose of explanation. So I'll have what summation F. So in place of D, I'll substitute what this what variable there. So that becomes what these variables I mean. So one, so just one variable. So that becomes what U and C divided by what my summation F plus what A. Okay. So what is happening here? We can further expand this by saying that I can rewrite this as what? Summation F U, right, over summation F, all right? I can say that all will multiply what? C, and I'll say plus what? A. So I can have this equation representing what? The mean for what? Coding what? Method. And this is how we find the mean using the coding method. So it's always what? Summation of what? F of U for the purpose of explanation. I'm not going to mention the mu, but I'll just use U for make it simpler for you to understand. So summation F of U over summation F, all multiplying what? C being the class width plus what? A being the assume what? Mean. So from the assume, you're able to get what? The coding what? Mean in that line. So this the three ways of calculating what? That of what the mean in that line. So let's take note of that. These are the three ways for calculating what the mean in that line. So you have the normal mean, okay? We have the normal mean, right? We have what? The assume mean formula here, and we have what? The coding what? Method formula. So it was from one equation, we're able to get another one to be able to get the last part of this. So let's take note of that. Okay. So now that is for that of what? How to calculate a mean. Let's also proceed to look at what? The median for group data, and then that of what the mode. So that after that, we take a question on all these formulas we are trying to bring on board here. And I believe that is clear. Right. So that is for the group data for mean, right? So let's talk about what the median. So here we are just discussing the formulas. After that, we'll take a full set of questions to explain them better, that line. Okay. So now also to calculate the median for a group set of data, here's how it goes. We'll say that MED represent the median. Okay, let me write it well. Should always be equal to L, and I will explain these variables in that line. L plus half my bracket N over what? 2, or multiplying what? C. So the L is the class boundary of the median class. The L is the lower class boundary of the median what? Class. The N represents what? The total number of frequency. under consideration, or the total number of observations under consideration. The CFM represent the cumulative frequency of the median what class. So here it is what the cumulative frequency preceding what the frequency preceding the median what frequency. Let me take it again. The CFM here is the cumulative frequencies preceding what the median what frequency, right? So those frequency that comes before the median frequency, we just sum up their totals and put that value what here. And then the FM here is what the frequency of what the median what class, the frequency of the median what class. And the C, as you know, is what the class width, is a class width in that line, is a class width in that line. So let's take note of that. Let's take note of that. Let's take note of that. So that is how we also calculate what the median for a group set of what data. As I said, we'll take a question to actually explain all of them in that line. So let's take note of that. So that is for the median in that line. Let's move on to talk about the mode so that we'll take a full set of questions. Let's talk about the mode. So with that of the mode 2, we also follow the same pattern. So to calculate, instead of the lower class boundary of the median what class, is going to be the lower class boundary of the modal what class. Simple, right? So L plus open brackets P1, right? And I will explain these values divided by P1 plus what P2, and then all multiplying with C. So now you know that the L represents the lower class boundary of the modal class. The P1 here is the difference between what the modal frequency and that of what the preceding frequency. The next preceding, by preceding means that the frequency that comes before, immediately before what the modal what frequency, right? And then that of P2 is also the difference between the modal frequency and that of what the next immediate what frequency that comes after, immediately afterwards, the modal what frequency. So the difference between the two will get at this value here, and the C, as always, is the class width in that line. So let's take note of that. If you have any question, can drop in the comment section and we'll take it from there. So I repeat myself again, the P1 represents what the difference between the modal frequency and before frequency of that modal value. So I mean that the frequency that comes before the modal frequency, the difference between the two will fetch as the P1. And the P2 is the difference between the modal frequency and the next frequency, or the succeeding what frequency, and the C represents what the class rate of the modal what class, or the width containing what the modal what class in that line. So let's take note of that. So this is what we need to understand when it comes to the group set of what data. And let's take our question to actually explain all these three uh, measures of central attendance we have discussed in terms of group data formula approach. So we have this set of data coming. In this set of measures of centrality for group data we are discussing. Please do want to like the video and share so that others will get a benefit to always to watch from us on this channel. Please do want to share the video, share to an interested student. So we have this data. We are asked to use the data below to answer the following questions for. So answer mean. So we have what? Very fast. Answer mean. So mean here, the mean for a normal mean, okay? Then that of what? The assumed mean, and that of what? The coding. How to find mean using the coding method. And then median for group data, and lastly, that of for the mode. Okay. So this is the data that we are asked to use. So we have the class interval. So I use what? CI to represent class interval. And we have the frequency F. So we have what? 1, 3, 4 to 6. And we have 7 to 9. And we have 10 to 12. And then we have what? 13 to 15. Right? So we are asked to use this data. Let me come back with the frequency. The frequency are what? 7, 10, 6, 9, and that of what? 5. Okay. Find the mean, the normal mean, the assumed mean, and that of the coding mean, right? And then find median, then that of what? The mode. So let's begin by finding the how to find what the mean using the general formula, the normal mean in that line. So in that line, this is what we're going to do. We'll say that to find the mean for a general mean or a normal mean, it is what? Summation f of x over what? Summation what? F, right? So it means that we need to have a column that represents x and a column that represents what? Summation f of x. I hope we are there. Yeah. So in that line, we're going to have what? Our value of what? X. To find the value of X for a group data, it is always the midpoint of what? The class interval or the class what? Boundary. It is always what? The midpoint of the class interval or the class boundary. And how do you find that midpoint? What I want to do here, especially for the class interval, you just have to add the upper class limit and the lower class limit and the upper class limit. You add them together and then divide by what? 2. Whatever you get becomes what? The midpoint, and that will be the value of what? X for each class. So we add 1 plus 3, and we are getting 4. We divide by 2, we are getting what? 2, right? We are getting 2 in that line. So we are getting 2 here. Then 4 plus 6 is 10. Divide by 2, we are getting what? 5. 7 plus 9, 16. Divide by 2, we are getting 8. 10 plus 12, we are getting 20. Divide by 2, we are getting what? 11. And 13 plus 15, you are getting 28. Divided by 2, you are getting what? 14 in that line. Okay, so that becomes the value of x as being the midpoint, right? So let's take note of that. So once we get that, the next thing we want to find is also find what? Our f of x. So how would you find our f of x? It is simply what? The multiplication of what? Frequency of each class by what? The value of what? X, right? So it is 7 multiplied 2 in that line to result the next. So 7 multiplying 2, you are getting what? 14. Then 5, you are getting 50, right? Then 6 multiplying 8, what are we getting? We are getting what? 48. Then 9, 11, we are getting 99. Then 4 by 14, what are we getting? Sorry, 5 by 14, what are we getting? Yeah, 5 by 14, what are we getting? Oh, I wrote here to be 5. No, here it's supposed to be 8 in that line. Supposed to be 8 rather. So sorry for that. Supposed to be 8. Because at the end of the day, you must get the frequency to be 40. So what are we getting? When we multiply 8 by 14, you should be able to get what? 1, 1, 2. Let's see if that is true. So 8 multiplying what? 14. Yeah, I should be able to get 1, 1, 2 in that line. So let's take note. So once you're able to get that, that's fine. So therefore, we say that to find the mean, so that is I part, using what the normal or the general mean, it should be equal to what? It should be equal to the summation of what? So let's find summation of what? F of x. We're going to add all these values together and also add what all these frequencies together. So what are we getting here is 8 actually. So when I add all these, I had what 40. And when I also add all these values, I was getting what 3, 2, 3. You can also confirm and let's see if that is true. 3, 2, 3 by adding all of them. So therefore, to find the normal mean or find the mean using the normal approach, it should be what 3, 2, 3 divided by what 40. And what are we getting? Supposed to get what? You're supposed to get 8.075 of what data. So let's take note of that. Then the next one we're asked to find is to find using what the assume mean. So under the assume mean, we are going to assume the mean to be a particular what value. And we always use what the values of x to assume what the mean. If the group data then is going to be what the value of x, right? Made point. That's what we're going to use to assume what the mean. So I can say that let's on always to the assume mean should always be a value that is what a bit halfway between what both ends of the data. So by that way, it should be at least the middle value of what the data. You can use that or the next value that comes after the middle value of what the values of x. I hope you get that. So in that line, I can assume that let the assume mean be equal to say what 8. I can assume from here that let the assume mean be what 8. So if I'm using assume mean of 8, that's fine. Then I will say that having that, my assume mean is what 8. So I will assume that my mean is what 8. So I will say that a should be equal to what 8. Okay, so if we have assume mean, then meaning that there's possible of what deviation. So we must find what our deviation. Is that okay? All right. So how do you go by that? You go to the value of x minus the assumed mean. Okay, so that's what we're going to use here. So the x values are 2, 5, 8, 11, and 14. And then assuming is what the 8 that we have assumed. So this is what we're going to do. So whenever we see minus 8, we are getting what 6. So once you're able to find the deviation values, that's fine. The next thing is that since we are using assume mean, the formula says that in finding assume mean, it should be what summation of what fd over summation f plus what the assume mean, which is the a. So mean that we need to have a column for what fd being what multiplication of what frequency and the deviation. So we're going to have a column called what fd. Okay, right? So mean that you're going to multiply each frequency by what each deviation in that line. So you multiply 7 by negative 6 and we are getting what negative 42. 10 by negative 2 we are getting negative 30. 6 by 0 we are getting 0 here. 9 by 3 we are getting 27. Then 8 by 6 we are getting what? 48. I hope you are following, right? So in that line, once you're able to find that, that becomes what your FD. So you find the summation of what our FD, right? Represent the frequency multiplying with the deviation. So let's do that. So negative 42 plus negative 30 plus 0 plus 27 plus 48. With my case, I had a total of what? I had a total of what? 3. 3. I had a total of 3. You can also cross-check and let's see if that is true. I had 3. So in that line, once able to satisfy FD, and I know my F, summation F, and I know that of my A, which is what the 8. Therefore, I will say that using assuming it should be equal to summation FD is what 3. So I'll have what 3 divided by summation F, which is what 40, plus my assuming of what 8. So what are we getting here? When you divide 3 by 4, you should be able to get something like 0.075 plus 8. And we are getting what? 8.075. So at any time you use the assuming or any formula aside the normal way of calculating the mean, at the end of the day, you should be able to get a value that is close to the normal mean, right? Or when you approximate it, it should be close to the normal mean. So here, it means that we're able to assume correctly, and we're getting what? The assuming to be what? 8.075, and it was the same thing as the normal mean of what? 8.075 in that line. So let's take note of that. So that is how we use the assume mean. Just assume a value and then use that to calculate. You can also assume, as I said, in assuming, you must use what? the middle value of what the values of data, right? Between the two, between the set of S values, the middle value, just use that one, or the next value, or the next preceding value, or the next value that comes after the middle value. You can use these three values. So in this case, we can probably should have used, let's say, 5, 8, or what 11. These are the values you can use for this is just small data, so probably for you to ensure accuracy of your assuming, you just have to use what the middle value of what 8. If it were to be a large data, then you have to go by that way and you have been what okay in that line, right? And at the end of the day, you're going to get a value that's a bit close to the normal way of calculating what the mean. So that is the assume mean approach. And then I that is being the mean for using the coding method. The same what are the coding methods? It says that it is what summation fu over summation f, or multiplying what c, representing what the class width plus what a. So that should tell us that we need to have what a class, the upper class boundary and the lower class boundary of a particular class. The difference between the upper class boundary, right, and the lower class boundary of a particular class. This is how we find a class rate in that line. So it means that we need to bring in what our class boundary. So I'll use CB to represent what the class boundary. So let's see, how do you find a class boundary? So to find a class boundary true, that's also very simple. It is always what the difference between what the lower class limit of the first class the difference between the upper class limits of the first class, compare that to the lower class limits of the second class. The difference between the upper class limits of the first class, compare that to the lower class limits of the second class interval. The interval. So in this particular case, I will say that boundary, I'll find the difference between this, and that should be what 1, right? I also find the difference between 6 and 7, that should be what 1. Difference between 9 and 10 is what 1. So once you're able to get that difference, that is fine. At the end of the day, once you get that difference, we then divide by what 2. So we'll say that here our class boundary, we'll first find the difference. The difference, I'm using these two classes, 1 and 3, and then 4 and what 6. So I will say that my difference presented a D should be what 4 minus what 3. Compare the lower class limit of the second class that to the upper class limit of the first class. I'm getting what 1. Once I'm able to get 1, then I need to find what a mark that will separate or mark a midpoint between one set of class values as against another. And by that way, we divide what D by what 2, and we are getting what 1 over 2. And 1 over 2 is the same thing as what 0.5. Once you're able to get the 0.5, then all I'm going to do for me to find my class boundary is that I will subtract the 0.5 from the lower class limit and then add 0.5 to the upper class limit of each class. Subtract 0.5 from the lower class limit and then add 0.5 to the upper class limit of each class in that line. So 0.5 from 1, I'm getting here to be what? 0.5. Then my hyphen, then add 0.5 here, I'm getting what? 3.5. Right? Then it goes on and on like that. So I have here to go 3.5, then 6 point what? I have here to what? 6.5. Okay. Then I have here to be 6.5. Compare that to here to be what? 9.5. I also have here to be what? 9.5. Compare that to 12.5. Just the interval. And then here becomes what? 12.5 to that of what 15.5. So once you get this value, that is fine. This is how you find a class what boundary. So after getting your class boundary, then you continue to find our class what size or class what width, class size or class width. Okay, and that is the difference between what the lower class boundary of a particular class compared that to the upper class boundary of a particular class. The difference. So we'll find the difference between what 3.5 and 0.5. You are getting what 3. Here you should get 3, 3, 3, and 3. So as I said, when it comes to the coding method, it makes use of what equal class interval. It makes use of